Lesson 4-3. There are two main points to this lesson. The first one is learning the difference between a linear function and a nonlinear function. The second one is being able to figure out what the function is. So first let's start with this. Last section we talked about linear functions. Those are functions that create a line. Linear means it makes a line. If it's a nonlinear function, then when you plot the points on a graph, it doesn't make a line. Pretty easy. Linear function makes a line, nonlinear function doesn't make a line. Take a look at page 246 in your book. They've got several examples on the bottom of the page. These on the top are all linear functions. This one and this one are lines. This one would be a line if you connected the dots. These three are not linear functions. They are nonlinear functions because they do not make one continuous line. This one is two lines, doesn't count as a linear function. And so problem one involves pizza, so I know that Tyler's happy. You've got two graphs that have to do with pizza. One is concerned with the area of the pizza, and for the x value, they give you different radius measures of the pizza, or different radii. And for each radius, what's the area of the pizza going to be? This other chart gives you different weights of the pizza for your x value, and your y value is the cost of the pizza. All they want you to do, or all they're going to show you, is how to plot these on a graph. The first thing you need to think about is the spacing that you're going to use on your graph. You see, for the pizza area, your x values, they went up 2, 4, 6, 8, 10, which makes sense because those are the values that they gave you here. But using that same scale on the y-axis isn't going to work because we need to do something that's going to represent 201, 314. You are not going to do a graph with 300 little squares in it. So how do they solve that dilemma? Oh, look at that, they go up by hundreds. And so then they estimate. The y value that goes with 2 is 12.57, so they just put it pretty close to 0. Then with 4, you're halfway to 100 at $50. Sorry, this is not money. At 50 inches squared, a little over. Then when 6 is your radius, you're just over 100. And so on to plot all these points. Then, after they have the points plotted, they drew a line. And you can see pretty clearly that is not a straight line. So this is a non-linear function. Then they went on to cost. And again, your first step is how do you do the scale on your graph? Well, take a look at your facts, your points to plot. The x values go up by 2's. So you can use the same scale across the bottom. Your y values start at just under 1 and go up to 4. So you can use the same exact scale on the y-axis, 2, 4, 6. And they plotted all the points, and you can see very clearly when x is 2, y is just under 1, it's 80 cents. When x is 4, y is $1.60, almost up to 2, and so on. This one is a straight line. This is a linear graph. That's all they want you to, all they want to know, is it linear or nonlinear? So you get to practice this now with Got It number 1. They've given you the numbers to plot. Figure out what the scale is going to be on your graph. You must use graph paper. Get this drawn, and then check your graph with mine. You know what I mean. So the first thing I did was just rewrite the points that they gave me in coordinate format, x, y, x, y, x, y, x, y. And so then I went to draw my graph. And I said, okay, my x values, 1, 2, 3, 4, fantastic. My y values, I need 1/16, 1/8, 1/4, 1/2. So I'll just go right up this side. And then I realized that that didn't work at all. Why? Well, because I'm using even amounts of space here, which works okay for 1/16 and 1/8 because 1/8 is the same fraction as 2/16, and so that's good. But 1/4 is not 3/16, it's 4/16. So I would need to go a little higher for that. Oh, do you hear my dog barking? And 1/2 is 8/16. I need to go way, way higher for that. This graph doesn't work. It's not showing an even scale here. I think I'm going to go let the dog out. I'll be right back. So I apologize for the interruption. I'm sure you missed me while I was gone. So anyway, like I was saying, this scale doesn't work because it's not anywhere close to even. You need to do something more representative. So I tried again. The x-axis worked just fine, 1, 2, 3, 4. But then, for the y-axis, I actually plotted it in 1/16 of an inch. So 1/16, 2/16, 3/16, 4/16, 5, 6, 7, 8/16, and then I could plot my numbers evenly. I had 1 and 1/2, 2 and 1/4, 3 and 1/8, 4 and 1/16. So you're looking at that, oh wow, that's really spaced out. I can't tell if it's curved or straight. Take a straight edge. Is it straight? As soon as you compare a straight edge to it, yeah, you cannot get more than 2 of those points together. And you can draw a nice curvy line that connects them. This one is not a linear function. They ask you a question, will this ever actually get down here to 0? What do you think about that? If you continue cutting it in half, if you could cut infinitely small pieces of paper, would you ever get to 0? Just think about that. I don't need to know. Wait.